The snowpack over your head splits in two right in front of your eyes and starts tumbling down in the frozen slope to its resting place far, far below. Anything in its way is crushed under the immense mass of snow and debris. You're witnessing an avalanche, one of the most dangerous natural disasters. But what if I tell you about another kind of avalanche, no less blood-chilling than the mountain one? And the most bizarre thing about it is that it occurs underwater. Underwater avalanches are powerful and disastrous natural phenomena, often much more dangerous than land ones. They have the potential to wreak havoc on the entire planet, leading to catastrophic consequences. The most alarming thing? They occur all the time under the surface of the ocean, impossible to see, predict, and extremely difficult to measure. Such avalanches can get 100 times larger than land ones, and they pose a great risk to the world's communications, capable of leaving the entire planet without the internet. But we'll talk about it a bit later. First, let's go 60,000 years back into the past. We're near the northwest coast of Africa, ready to witness the colossal scale and devastating impact of a ginormous underwater avalanche. It started as a quite small underwater landslide in the Agadir Canyon. At first, it was just 0.35 cubic miles of material, but in no time, this mass increased more than 100 times in size while traveling across the Atlantic Ocean floor. As the avalanche sped up and grew, it picked up gravel, sand, rocks, and mud. It carved a devastating path through one of the world's largest submarine canyons, wiping out all forms of animal and plant life on its way. The disastrous flow was so powerful that it literally eroded a 250-mile stretch of the canyon, cutting hundreds of feet into its sides and damaging a total area of 1,740 square miles. That's the area of more than 3.5 New York cities. As for the force of the flow, it was so immense that it propelled massive boulders up the canyon walls to heights of up to 430 feet. Before scientists discovered the evidence of this catastrophic event, they had seriously underestimated the scale of destruction caused by submarine avalanches. By the way, these devastating catastrophes can start not only far away in the ocean, but also at estuaries. Let's go back to 14 January 2020 and see for ourselves. A turbidity current, a rapid, downhill flow of water containing a lot of sediment, rushed more than 680 miles from the Congo River estuary in the deep sea. This current appeared due to two factors: terrible flooding along the Congo River in late December 2019 and unusually large spring tides. This resulted in an avalanche of sand and mud. Its volume was equivalent to 1/3 of all the sediment produced annually by all the rivers in the world. This sediment avalanche accelerated, increasing in speed from 17 feet per second in the upper part of the Congo Canyon to 26 feet per second when it reached the end of the channel, almost 700 miles away from the coastline. This route made it the longest avalanche of sediment ever measured on our planet. 2 days later, the flow reached the deep ocean. The avalanche broke two seabed telecommunication cables, cutting internet data speeds all the way across West, Central, and South Africa. Now, before this disaster, scientists considered that measuring powerful deep-sea avalanches was impractical. But the sediment flow in the Congo Canyon could be monitored directly, finally allowing researchers to assess how major river floods connected to the deep sea. They also concluded that how often underwater avalanches occurred depended on where the observer was. Seafloor canyons that are close to river mouths can experience several tiny avalanches per year. Other systems, far from river discharges like the Agadir Canyon, can only have one monster of an avalanche every 10,000 years or so. You're likely wondering, what can trigger an avalanche under the surface of the ocean? Well, earthquakes, typhoons, high tides, river floods, and even volcanic eruptions. And due to our changing climate, such events become more and more frequent and intense. At the same time, these triggers don't mean that an avalanche is bound to happen, nor do they relate to the scale of the event. See for yourself. In 1755, a powerful earthquake hit the coast of Portugal, wiping out large parts of Lisbon. Tens of thousands of people lost their lives during that disaster, but it only triggered a tiny underwater avalanche. And in 1929, a large earthquake off the coast of Newfoundland, Canada, triggered the largest underwater avalanche ever recorded. The flow traveled at a speed of 42 miles per hour, carrying boulders, sand, and mud. It snapped 11 seabed cables on its journey downhill. The avalanche was so powerful, it produced a tsunami that claimed the lives of 28 people along the coastline. Now, submarine avalanches are totally invisible because they happen deep under the ocean surface, which makes them extremely hard to study. But we must find a way because these flows are super important. They transport sediments, nutrients, and even pollutants across the ocean floor. So, a research team from Liverpool decided to unravel this mystery. Over the last 40 years, they've collected more than 300 samples from the ocean floor. Combined with seismic and bathymetric data, which is a fancy word for ocean mapping, they managed to reconstruct a massive submarine avalanche. It was the first time an underwater avalanche of this size was mapped out. An even cooler thing, the event itself started off pretty modestly, but it quickly evolved into a colossal avalanche that grew to more than 650 feet tall. To put that into perspective, imagine a skyscraper-sized avalanche zooming from Liverpool to London, cutting a trench 100 feet deep and 9 miles wide. Then it spread out over an area bigger than the UK, covering it with several feet of sand and mud. That's like burying a whole country. These findings are actually a big deal because they show that even a small underwater landslide can turn into something massive and super destructive. But that's not the worst. Think about undersea internet cables, which are essential for global communication. There are more than 550 active seafloor cables around the world. Their combined length is a whopping 870,000 miles. That's enough to wrap around our planet 35 times. When a submarine avalanche breaks seafloor cables, the effects are usually super expensive and devastating. For example, in 2006, an earthquake in Taiwan triggered underwater avalanches that cut loads of seafloor cables connecting Southeast Asia with the rest of the world. The largest internet operator in China had a 90% loss of traffic to the USA at the peak of the event. As for Taiwan itself, it experienced between 74 to 100% loss in traffic to neighboring islands. So now you probably get why we need to learn more about this natural phenomenon. Luckily, researchers at Tulane University have found a way to study it in 3D. Previous studies only looked at submarine avalanches in 2D, which didn't give the full picture of how they actually behaved. The new research focused on how underwater flows interacted with mini basins, natural features on the ocean floor that look like shallow bowls. Despite being called mini, these bowls can be huge, up to 4 square miles. When turbidity currents flow into these mini basins, they don't just stop. No, they hit the far side and curl back around like water eddies in a stream. These swirling flows move the sediment around before it settles on the ocean floor. The size of the mini basin and the speed of the flow can change how the current behaves. If the basin is big and the current is slow, it starts to fill up with sediment. But if you crank up the flow speed or shrink the basin, the current starts to overflow, spilling over the basin. To study all this, the researchers created a mini version of a mini basin in a pool and used different speeds of flow to simulate turbidity currents. They even made their own sediment mixtures to see how different sizes of particles would behave. In the end, they managed to mimic real-life ocean conditions, but on a smaller, manageable scale. Pretty cool, huh?
So this huge volcano, everyone thought to be extinct, woke up and spat out a black ash cloud 50 miles high. That's about 9 times as tall as Mount Everest, located in what is now Indonesia. The powerful Krakatoa had caused huge tsunamis that rocked over ships as far away as South Africa. It also changed the temperatures around the world for several years. The volcanic island of Krakatoa in the Sunda Strait was likely born thanks to another major eruption several centuries ago. It hadn't erupted for at least 200 years before 1883. So the first tremors and blasts in May of that year came as a total shock to people living nearby. Then ships sailing through the busy water passage started reporting clouds of ash above the volcano. It went quiet again for a while, but they could still see ash above it. The eruption culminated at the end of August. It was so powerful that it shattered the island into fragments. Witnesses heard the sound produced by it in Australia, around 3,000 miles away. They described the noise as the roar of heavy cannons. Some say it was the loudest sound ever heard. During the next 5 days, the pressure wave from the eruption traveled around the globe 3.5 times and was seen on barographs on different continents. Hot avalanches of ash spread down the volcano as far as 25 miles away at crazy speeds. They ruined the surrounding islands and took 36,000 lives. Tens of thousands more drowned in tsunamis that happened after the volcano had collapsed into the caldera. Over 100 coastal villages on Java and Sumatra were completely wiped out. All this made the waking up of Krakatoa one of the most devastating in the entire recorded history. The Earth's crust is like a giant puzzle, made up of massive pieces known as tectonic plates. These plates are constantly sliding against each other over the mantle, which is the molten layer beneath. Indonesia is right in the middle of the so-called subduction zone. Here, the Indo-Australian plate collides with part of the Asian plate as it moves northward. As the oceanic plate dives down, it gets heated up, and you've got the perfect recipe for a volcanic hotspot. Krakatoa had 3 peaks, each serving as an exit door for a massive magma chamber beneath it. During a previous eruption, debris blocked one of these exits, and the pressure built up beneath. When Krakatoa finally blew its top, the blast split the magma chamber wide open. The eruption led to a so-called volcanic winter. Krakatoa had sent 6 cubic miles of rock, ash, and debris into the atmosphere. They created a thick veil that surrounded the Earth. The particles scattered sunlight, and the troposphere below cooled down. The effect stayed strong for several years. The Northern Hemisphere experienced colder than average temperatures, and in some regions, summer temperatures didn't rise to typical levels. Southern California received a record amount of rainfall in the months following the eruption. The sky became darker in different parts of the world for years afterwards. The sunsets, for many months, turned into a spectacular show of red and orange. One astronomer supposed it was the source of the inspiration for The Scream by Edvard Munch. The painting shows exactly what the sky over Norway looked like after the eruption. It also produced a rare type of halo called Bishop's Ring and a volcanic purple light at night. For several years after Krakatoa had blown up, the moon looked blue and sometimes green. That's because some ash clouds were full of particles large enough to scatter red light, only letting other colors pass. Someone even witnessed lavender sun and night-shining clouds. Krakatoa became the first scientifically well-recorded and studied eruption of a volcano. Between the moments the first clouds of ash were seen by a ship passing by and the disastrous eruption, scientists managed to organize geological expeditions. They studied the volcano and gathered samples of volcanic rocks. It became useful for understanding volcanic activity. Krakatoa was sleeping tight until the 1920s, when some locals noticed a column of steam and debris spewing from the collapsed caldera. Within weeks, the rim of a new cone sprang up above sea level. After a year, it was a small island named Child of Krakatoa. It continues to erupt, but fortunately without serious consequences so far. In April of 1815, Mount Tambora unleashed a massive eruption, wreaking havoc on the Indonesian island of Sumbawa. It destroyed homes and claimed 10,000 lives. Another 80,000 perished because of diseases that spread in the aftermath. The following went in history as the year without a summer. Cold, wet conditions wrapped Europe and North America in an unexpected chill. It became the coldest in at least 250 years. In the summer of that year, the temperatures dropped the most. Crops didn't grow, livestock didn't survive, and famine took over Western Europe and North America. New England had snow and terrible frost in the summer months. Food prices went up. Oats for horses became a luxury. Some people say it even inspired the invention of the bicycle in 1817. Scientists used early data and climate models to see if it was all because of the Tambora eruption. They compared the data to similar years. They showed that precipitation was around the same, but the temperatures were much warmer. When they introduced the volcano into the scenario, they got the exact data for the year without summer. They say that a powerful volcanic eruption like that one increases the likelihood of extreme cold by up to 100 times. The explosion of the Toba supervolcano on the island of Sumatra around 74,000 years ago became the Earth's largest volcanic eruption in 28 million years. Parts of Indonesia, India, and a slice of the Indian Ocean got a cozy blanket made up of 6 inches of volcanic debris. It spat out a volume of rock comparable to almost 3 million Empire State Buildings. The crater it had left behind is still seen from space. All the ash and volcanic gases that sprang into the atmosphere because of the eruption partially blocked the sunlight. A severe volcanic winter began and lasted for 6 to 10 years. Some anthropologists see a connection between the Toba eruption and how limited modern humans are when it comes to genetic variety. Around 74,000 years ago, exactly when the Toba erupted, there was a population nosedive. That's why all modern humans trace their roots back to a tiny group of survivors. The Toba catastrophe theory proposes that most early humans in Europe and Asia didn't make it through the post-eruption climate chaos. Instead, a lucky, genetically limited bunch found their safe haven in Africa. But archaeological and paleoclimate records disagree with this theory. Benjamin Black from Rutgers University and his team set out to crack the code and discovered a hidden paradox. Maybe we were peering through the wrong climate lens. They ran 42 different climate model simulations, varying the magnitude of volcanic emissions, time of year of the eruption, background climate state, and eruption column height to see what climate disruptions the Toba eruption might have caused. There was a significant drop in temperatures in the northern hemisphere in the first year after the event, up to 18 degrees Fahrenheit. The southern hemisphere, where the early humans were settling, didn't go through a rough cooling that could have affected them all. The most significant eruptions that can seriously change the world's climatic patterns come from supervolcanoes like Yellowstone or Mount Toba. Luckily, these erupt very rarely, about every 100,000 years or more. Still, climate scientists study volcanic eruptions to understand and explain short periods of cooling in the history of our planet. Every few decades or so, a volcanic eruption lets out a substantial number of particles and gases. Some of them will block enough sunlight to start a brief global cooling period. Nothing like the real volcanic winter, but still felt across the globe. Oh boy, scientists predict a volcanic eruption that is likely to be one of the most destructive in the history of our species. There's a 1 in 6 chance of it happening in this century, and it could seriously change the climate even more and put millions of lives in danger. Back in January 2022, the Hunga Tonga Hunga Ha'apai volcano erupted in the South Pacific Ocean, creating a huge explosion. It sent tsunamis all the way to Japan, North America, and South America. Tonga itself was hit hard, with damage costing nearly 20% of the country's entire economy. Now, researchers at the Niels Bohr Institute in Copenhagen have studied ice samples from Greenland and Antarctica, and their findings are worrying, predicting potential global volcanic disaster. They say there's a real chance of a much bigger eruption, a whopping 10 to 100 times larger than Tonga's. In the past, eruptions this size used to change the climate and even cause civilizations to collapse. Despite future volcanic eruption risks, Experts say the world isn't prepared at all. Michael Cassidy, a volcanologist from the University of Birmingham, warns that no sufficient effort is made to handle a disaster like this. He says that NASA and other space agencies spend billions on asteroid defense. At the same time, a volcanic supereruption is way more likely than an asteroid impact. And right now, there's no global plan for dealing with a massive eruption, even though it's likely to be far more destructive. The last magnitude 7 eruption happened in 1815 at Mount Tambora in Indonesia. Then, thousands of people lost their lives in just a few days. The disaster also disrupted weather and caused food shortages worldwide, affecting millions. That eruption was the biggest in recorded history. It blasted a massive cloud of particles into the sky. Those particles blocked sunlight, cooled the planet, and caused worldwide chaos. The year after the eruption became known as the Year Without a Summer. Temperatures plummeted, crops failed, famine spread, and a cholera pandemic broke out, leading to tens of thousands of lost lives. A shocking fact, the eruption may have even inspired Mary Shelley to write Frankenstein while stuck indoors during the unusually cold summer of 1816 in Switzerland. Now, since then, many volcanoes have erupted, but none have matched Tambora's scale. Now, over 200 years later, scientists warn that there's a new supervolcano threat. Another massive eruption could be on the way, and the world might not be ready for it. So, while scientists seriously discuss the likelihood of the next volcanic eruption, experts are calling for urgent action to prepare before it's too late. So, the thing is, a massive volcanic eruption today could be even more devastating than the Year Without a Summer. Unlike back then, we're already dealing with all kinds of weather changes and a more fragile global system, which could make the effects even worse. Dr. Michael Rampino, a geological scientist, warns that the world is more unstable now, and it means that a modern-day mega-eruption could have even more severe consequences. But this time, greenhouse gases from fossil fuels may make the aftermath of such an eruption even colder instead of warmer. So we're talking about volcanic activity endangering humanity. Dr. Thomas Aubrey, a volcanologist, found that in a hotter, more turbulent atmosphere, the sulfur dioxide gas released by a volcanic eruption would spread faster and farther than in the past. This gas forms sulfate aerosols, which reflect sunlight and cause global cooling. Because these tiny particles would be more evenly distributed, they'd have a stronger cooling effect than in 1815. Another atmospheric scientist at Cambridge explains that the size of these airborne particles matters. It affects how they absorb sunlight, and in a future warmer climate, an eruption could make the surface cooling stronger by 15%. At the same time, there are still many unknowns. Scientists from the University of Geneva say that we're only beginning to understand the full impacts of such an event. It's also difficult to precisely estimate future volcanic eruption risks, since we have very little data on older eruptions. So, to understand past volcanic activity, researchers analyze ice cores from Greenland and Antarctica, as well as ancient tree rings. Those act as historical records of weather changes. These measurements suggest that several eruptions in the past few thousand years temporarily cooled the planet by about 2 to 2.5 degrees Fahrenheit. One of the most catastrophic examples is the 1257 Somalus eruption in Indonesia, which was so powerful that it likely triggered the Little Ice Age. It was a period of global cooling that lasted for hundreds of years. More recently, the 1991 Mount Pinatubo eruption in the Philippines slightly cooled Earth for a few years. Because this eruption happened in the satellite era, scientists were able to measure exactly how much sulfur dioxide was released and how it affected the atmosphere. But even with modern tools like satellites and seismic instruments, scientists still have difficult times forecasting the next big volcanic eruption. Luckily, even though we can't predict the exact timing, we can study worst-case scenarios to help authorities prepare. This includes creating evacuation plans and stockpiling food in case of global crop failures caused by volcanic cooling. The changes in weather patterns might make volcanoes more active. Melting glaciers can reduce pressure on underground magma, which will increase the chances of an eruption. Plus, more extreme rainfall, which is becoming more and more common, can seep into volcanic cracks and cause powerful steam-driven explosions. It can affect both active and dormant volcanoes. Because of these risks, researchers are now mapping volcanoes that are the most vulnerable to climate change. Their studies show that the highest supervolcano threat comes from such areas as Iceland, Chile, and Indonesia. Those are places where glaciers are melting quickly or rainfall is increasing dramatically. A 2022 study found that 716 volcanoes worldwide, that's about 58% of all known active above-ground volcanoes, could be triggered by extreme rainfall, increasing the likelihood of another mini ice age. Now let's get back to that Hunga Tonga Hunga Ha'apai eruption that occurred on January 15, 2022. Scientists have confirmed that it created the highest plume ever recorded. The volcano, located underwater in the South Pacific, sent an ash cloud 187,000 feet high. That's higher than any previously recorded eruption. What makes this eruption even more remarkable is that it was the first to ever reach the mesosphere. It's the third layer of Earth's atmosphere. The mesosphere begins at about 160,000 feet above Earth, where meteors start burning up and creating shooting stars. To measure the plume's height, researchers from the University of Oxford and RAL Space used data from 3 geostationary weather satellites. Before this, the record for the highest volcanic plume was held by Mount Pinatubo's 1991 eruption in the Philippines, which reached 131,000 feet high. Interestingly, this kind of measurement was only possible thanks to modern satellite technology, and a decade ago, no one would have been able to do this. Another volcano we should mention in relation to a potential global volcanic disaster is located on Iceland's Reykjanes Peninsula. Its latest eruption happened in November of 2024, leading to evacuations in nearby areas. The eruption began just after 11 p.m. with little warning. The volcano released orange lava from a nearly 2-mile-long fissure. Authorities ordered evacuations for about 50 homes and guests staying at the Blue Lagoon Spa Resort, a popular tourist destination southwest of Reykjavik. While air travel was not affected, officials still warned of potentially dangerous gas emissions spreading across parts of the peninsula, including the nearby town of Grindavik. Grindavik, home to 3,800 residents, has repeatedly witnessed volcanic activity, and past eruptions even damaged its infrastructure and forced evacuations. For example, in August 2024, a 2.5-mile-long crack opened at the Sunthunkangigar crater near Grindavik. It led authorities declaring a state of emergency as lava flowed in multiple directions. Fortunately, Iceland's meteorological office reported that the latest eruption was significantly smaller than the one in August. Geophysics experts conducted aerial surveys and figured out that the situation appeared less intense than the previous eruptions. These days, Grindavik is not at risk, but the possibility of further developments cannot be ruled out. Scientists predict more volcanic eruptions. You're lazing around on the deck of the ship when you see something whitish-gray covering the horizon. Like in a horror movie or your worst nightmare, this weird fog is nearing the vessel. It's infinite. You can't see where it starts or where it ends. Soon it makes the ship look like a grain of sand in a vast desert. That's when the realization hits. It's an iceberg, and your ship is likely going to repeat the Titanic's fate. Now, all this is a very likely scenario, since the world's biggest iceberg, A23A, is on the move again after months of spinning in a huge water vortex. And it's actually the second time in just a couple of years that this massive chunk of ice has broken free. The first time was in 2023, when the berg went wandering around after being stuck on the seafloor for a staggering 37 years. The thing is huge, about 3 times the size of New York City. It also weighs nearly 1 trillion tons. The giant chunk of ice first broke off from Antarctica's Filsner ice shelf back in 1986, but instead of floating away, it got grounded on the seafloor just a few miles from where it started. Because of that, it melted much more slowly than most icebergs. In December 2023, A23A finally broke free and started to drift away from Antarctica. But it didn't get far before getting stuck again, this time near the South Orkney Islands. It got trapped in something called a Taylor column. That's a huge spinning water current that forms when ocean currents swirl around an underwater mountain. At one point, A23A was rotating around 15 degrees counterclockwise every day. Luckily, as of December 2024, the iceberg escaped the Taylor column and is now slowly moving again. Researchers are super curious to see if it'll follow the same path as other giant icebergs that have broken off from Antarctica, or if it'll find its own unique way. Such enormous icebergs, such as A23A, release nutrients into the water as they melt, and it can actually create hot spots of life in parts of the ocean that are usually pretty empty. But there's still a lot we don't understand about how the size, shape, or origin of the iceberg might affect that process. So, to figure it out, scientists have been collecting water samples from the areas A23A is expected to pass through, and they'll keep collecting samples as it drifts along. Hopefully, it'll give us a better idea of how massive icebergs like this one influence the ocean around them. By the way, the glacier our monster of an iceberg was once part of could be very, very old, literally ancient. In Antarctica, the oldest glacier ice might be close to 1 million years old. Over in Greenland, the oldest glacier ice is more than 100,000 years old. And in Alaska, the oldest glacier ice ever recovered, found in a basin between Mount Bona and Mount Churchill, is only about 30,000 years old, a mere child. At the same time, in a typical Alaskan Valley glacier, it only takes about 100 years for newly formed ice to travel through the entire length of the glacier. For something like Bering Glacier, which is Alaska's largest and stretches over 140 miles, the ice can move through the whole thing in less than 400 years, and that's a lot of movement for such a massive glacier. Now let's move on to Iceberg Alley, a stretch of the Atlantic Ocean that runs from the Arctic to Newfoundland. If you want to see as many icebergs as you can, that's the place to be. Tons of icebergs float through this place every year. Most of them come from Greenland. In spring and summer, big chunks of glaciers break off and get carried by north-south currents through Baffin Bay into the Labrador Sea, where they eventually melt. Some icebergs also come from Canada's shoreline, traveling through the Davis Strait and into the Labrador Sea before drifting along Newfoundland's eastern and western coasts. These massive ice chunks are really old too, about 10,000 years. Every year, about 400 to 800 medium and large icebergs pass through Iceberg Alley. How fast they drift depends on their size, shape, currents, waves, and wind, but the average speed is less than a half mile per hour. Now, there are 6 types of icebergs that make their way through Iceberg Alley. Tabular icebergs are flat slabs of ice, much wider than they are tall. Blocky icebergs have steep sides and sharp angles, like cut-off pyramids. Wedged icebergs have one steep side and one sloping side. Dome icebergs have a rounded top. Pinnacle icebergs have one or more steep peaks sticking up. And dry dock icebergs are U-shaped with a hollowed-out section. They all look incredible. Comment below which is your favorite type. Anyway, as these icebergs drift south, the warmer water speeds up their melting, making them pretty unpredictable and sometimes dangerous. Nowadays, satellites help track medium and large icebergs to prevent accidents, but smaller icebergs can still be risky for small boats. One iceberg made headlines in 2018 when it got unusually close to the Newfoundland village of Fairyland. Pictures of the giant iceberg towering over the village's houses went viral. It got stuck in a 330-foot deep water, which turned out to be too shallow for its massive size. And now, I'll take you on an unusual journey to the past to witness the birth of something beautiful and equally disastrous. Its very existence led to one of the greatest tragedies in history. Watch, an enormous chunk of ice is breaking off a glacier in southwest Greenland. It's made of snow that fell over 100,000 years ago, when mammoths were still wandering around the planet. The enormous iceberg starts its long journey. It stretches more than 1,700 feet in length and weighs 75 million tons. Despite its size, it's pretty peaceful and stays far away from ships and the busy transport routes near where it was born. But then, it starts floating south, much farther than most icebergs ever get. Usually, icebergs like this melt way before they reach such warm waters. Out of the 15,000 to 30,000 icebergs that drift away from Greenland's glaciers every year, only about 1% make it all the way to the Atlantic. So the fact that this iceberg keeps going and reaches over 5,000 miles south of the Arctic Circle by April makes it truly unique. Even after months of melting, this block of ice is still incredibly massive. It weighs around 1.5 million tons, which is almost twice as much as the Golden Gate Bridge. Above the water, its visible parts tower more than 100 feet high. But like most icebergs, the majority of it, about 90%, is hidden below the surface. The iceberg's story takes a tragic turn on April 14, 1912, when, guess what? Yep, it comes across the ocean liner Titanic. The ship is about 370 miles from Newfoundland in the North Atlantic Ocean when the iceberg seems to appear out of nowhere. The crew doesn't spot it until just minutes before the crash. Why don't they see it sooner? That's a good question. Now, most people imagine icebergs as tall, bright, white chunks of ice, maybe even covered with snow. But in reality, icebergs come in all sorts of colors. Some are striped, patterned, or even have candy-like swirls, and they can also be black. There are two ways an iceberg can turn black. When the ice is extremely pure, with no bubbles or cracks, then it absorbs all the light instead of reflecting it, making it look black. Or a volcanic eruption can cover a glacier in ash. If ice from that glacier breaks off, it can have a dark or black color. Now, scientists still aren't sure why the Titanic's iceberg looked dark, or even if it really did. But one sailor who was on the lookout in the crow's nest said it seemed black. Another described it as gray or dark gray. One theory is this iceberg could have been a blackbird, which forms when the top part melts, causing the iceberg to roll over. If the bottom is smooth enough to absorb light, it looks dark. But even if the iceberg wasn't truly black, nighttime could have made it much harder to spot. Icebergs don't reflect much light, especially if they're jagged or vertical. They end up blending into the dark, shimmering ocean. Without radar, icebergs at night are incredibly hard to see, which is probably why the Titanic's crew didn't notice it in time.
For hundreds of years, people in the US have reported hearing strange, loud booms. These mysterious sounds are called skyquakes. And yep, it's a real thing. If you've ever heard a loud, distant booming noise that definitely wasn't a thunderstorm or a car engine backfire, congrats, it looks like you've experienced a skyquake yourself. People report them all around the globe, from the US to India and Japan. They go under different names, and we still don't know why exactly they happen. Sometimes these booms come together with earthquakes. People heard them during the New Madrid earthquakes in the early 19th century and up until January 2020. Those who've experienced them describe skyquakes as a rushing or rolling noise. Famous American writer James Fenimore Cooper described it more poetically as the lake speaking to the surrounding hills, which send back the echoes of its voice in accurate reply. Sometimes these mysterious booms happen in cold weather instead of during earthquakes. One of the skyquake hotspots is near Lake Seneca in New York. They call them the Seneca Guns. The booms can be so loud that they shake windows and doors. Back in August 1886, after an earthquake in Charleston, people heard these noises for several weeks, happening at the same time as many aftershocks from the earthquake. In 2020, scientists from the University of North Carolina looked at old news pieces, especially from North Carolina, where people have often reported these sounds. They hoped to match the noises with earthquakes data, but they didn't find any link between the sounds and earthquakes. One of the researchers said they believe the noises are happening in the air, not underground. The team looked at infrasounds, which are low-frequency noises that humans can't hear. They found signals lasting 1 to 10 seconds that match the times when people reported hearing the booms, but nothing is certain here. Some people think that solar flares, underwater tsunamis, or caves collapsing under the sea cause skyquakes. Others believe the sounds come from planes making loud sonic booms. But that doesn't explain old records of skyquakes from the past before planes were even invented. Some scientists think a type of meteor called a bolide causes these booms. These meteors blow up when they hit Earth's atmosphere. If this happened above thick clouds, the sound would get louder and travel far, but we wouldn't find anything on the ground. Another idea is that gas might be escaping from the bottom of deep lakes, like Lake Seneca. If you think skyquakes are bizarre, let me introduce you to fog bows. They also go under the name of white rainbows, ghost rainbows, or cloud bows. They form in a similar way to regular colorful rainbows, but are much wider. Rainbows happen when there are big raindrops in the sky, and you can always spot them on the opposite side of where the sun is shining. Fog bows are made by tiny droplets in fog, or clouds, instead of big raindrops, and they also appear opposite the sun. If you want to see a fog bow, you need to look for it in a thin fog when the sun is bright. You might catch one when the sun starts to shine through the fog, or if you're near the ocean where fog often forms. Because the water droplets in fog are so tiny, fog bows don't have bright colors like rainbows. They might even look all white, or just have faint colors. Some fog bows are hard to see at first because they blend into the mist, but once you spot them, they're easy to recognize. The next rare weather phenomenon you gotta watch out for is thunder snow. You guessed it right, it's a special type of thunderstorm that happens during a snowstorm. Unlike regular thunderstorms that often strike in the spring and summer, thunder snow is much rarer because it happens in the strongest winter storms, like big blizzards, and at the same time needs warm air, which isn't a frequent combo. So, for thunder snow to happen, there needs to be moisture in the air, some instability, and something to lift the air, like rising winds. Just like in normal thunderstorms, lightning can appear when you hear thunder. Thunder snow lightning usually goes from cloud to cloud instead of hitting the ground, and the thunder sounds different too, more like a low rumble instead of a loud boom, because the snow muffles the sound. You aren't so likely to get struck by it, but it's still important to stay inside when you hear thunder to stay safe. Northern Lights fans, this one is for you. Scientists noticed a new kind of glow in the sky that looked like a purple streak. They nicknamed it Steve as a joke, but later gave it a more scientific name: Strong Thermal Emission Velocity Enhancement, Steve for short. Steve is actually a fast-moving stream of super hot gas that always moves west and only shows up before midnight. They wondered if something like Steve could happen after midnight, but moving in the opposite direction. And now, scientists think they found the anti-Steve by looking at data from a research station in Norway. In December 2021, they took a picture of a bright purple streak stretching for 620 miles in the sky, and it only appeared after midnight. Satellites from the European Space Agency also measured the conditions in this part of the sky and found that the ions were moving eastward. Steve's late-night twin hasn't been officially named yet, but it would be cool if it was called SAM, which is short for Steve After Midnight. If you've ever seen snow on a sunny day when falling from the sky without a single cloud, it must have been diamond dust. It's a special kind of weather with millions of tiny ice crystals forming close to the ground. These ice crystals float slowly in the air, kind of like how dust floats in your house. When sunlight hits these crystals, they sparkle like diamonds. Unlike regular snow, diamond dust can fall from a cloudless sky, which is why they sometimes call it clear sky precipitation. It happens because of temperature inversion. Normally, it gets colder as you go higher up from the ground. But in a temperature inversion, the cold air stays near the ground, and warmer air sits above it. The warm air has more water vapor, and when it mixes with cold air near the ground, it turns directly into ice crystals, and diamond dust is born. For this to happen, the air near the ground has to be really, really cold, way below freezing temperature. Diamond dust can fall for days, but it's so light that it usually doesn't pile up on the ground like regular snow. A fall streak hole, also known as a hole punch cloud, is next on our list. This big circular or oval-shaped gap sometimes appears in certain clouds. These types of clouds float high up in the sky and are often made of tiny water droplets that are colder than freezing, but they haven't frozen yet. These special water droplets are called supercooled, and they need a reason to freeze. Ice crystals give them that reason. When a plane flies through the cloud, it can bring those ice crystals into the cloud. Once the ice crystals are there, the supercooled water droplets freeze quickly, get bigger, and start to fall from the ground. This creates a hole in the cloud, and as more nearby droplets freeze, the hole gets bigger and spreads outward. Any tornado is scary, but a fire tornado takes the horror to a new level. These bad boys are spinning towers of flame and ash that form when there's extreme heat, strong winds, and uneven ground. The intense heat from the fire causes hot air to rise quickly. Cooler air from the sides rushes in to replace it and creates strong winds. When winds from different directions meet, it makes the fire spin like a tornado. It gets stronger and can even create its own weather. It pulls in flames, ash, dirt, and anything in its path. The winds can reach speeds of over 140 miles per hour, and these fire tornadoes can last for more than 20 minutes. Phew, you can finally send that last report for the day and breathe out. The weekend is around the corner, but just when you're about to hit send, you're alarmed by the low rumbling under your desk. Is it the light rail passing by? Unfortunately, that's not the case. It's a volcano speaking. What, here? In Arizona? That's right, the ground keeps shifting under Arizona, reminding us that Earth is alive. No panic though, let's arm ourselves with some context. 20 American states have extinct, active, and dormant, currently sleeping, volcanoes. Among such states, you can find California, New Mexico, Nevada, Utah, and Colorado. On the bright side, Arizona's volcanoes are dormant at the moment, but it doesn't mean they won't go off in the near or not so near future. Now, how about traveling to Arizona to check the traces of its active volcanic past? They dot the desert landscapes of this state like spots dot a Dalmatian. There are entire volcanic fields southwest of Phoenix, east of Douglas, near Flagstaff, north of Kingman, and near the Mexico border. The most worrying thing about these fields is that even though they're not active at the moment, eruptions in this region might happen every 1,000 years or so. Well, the time seems to be up. The last powerful and destructive volcanic eruption occurred around 1,000 years ago at the Sunset Crater. Oh, this place is worth paying more attention to. And we will, but a bit later. First, we have to talk about hotspots. No, not that place where you can surf the web. In our volcanic context, a hotspot is a place where insane amounts of heat melt the overlying crust, Earth's thin outer layer, and form volcanoes. This heat rises from the mantle, which is located between our planet's dense, superheated core and the crust. Want to see an example of this type of volcanism? Welcome to the Hawaiian Islands. The Big Island has its active volcanoes because, at the moment, it's situated on top of the Hawaiian hotspot. The older Hawaiian Islands were once there too, but later they drifted off towards the northwest. It happened because that's where the oceanic crust on top of which they sat, namely the Pacific Plate, moved. Now, look at the world's ocean basins. Yes, they're literally dotted with islands that sit on top of hotspots, like Hawaii, Iceland, Samoa, the Galapagos. Those are probably the most famous examples. But don't think that continents can't host hotspots. They can, but those are far less common. One of the most famous continental hotspots is, I bet you know it. Yep, the one beneath the Yellowstone caldera. By the way, the caldera is a vast volcanic crater, especially one formed as a result of a massive eruption that led to the collapse of the mouth of a volcano. The Yellowstone hotspot is basically the creator of Old Faithful and the rest of the hot springs and mud pots for which the national park is famous. Speaking of Old Faithful, let's make a small detour and pay more attention to this wonder of nature. It's one of the most well-known geysers in the world. People have been coming from all over the globe to see it for more than a century. The cool thing about this geyser is that the likes of it can only form under very specific conditions. That's why they're pretty rare. Magma under the surface superheats pockets of underground water. The pressure there keeps growing until it eventually pushes the water upward with immense strength. A certain volcanic rock with a high silica content lines the tunnel through which this water escapes. Basically, it creates a unique pipe that can withstand unbelievable pressure and heat created by the water erupting above the ground. Old Faithful was the very first named geyser in Yellowstone. If you come to visit it expecting the thing to erupt every hour on the hour, you're gonna be disappointed. On average, Old Faithful erupts every 91 minutes or so, which isn't that bad either. Plus, you can download a special app which will provide you with the approximate time of the next eruption. But be very careful while visiting and stay away from the site. The water erupting from the powerful geyser reaches 204 degrees Fahrenheit. The steam is even more scorching, up to 350 degrees Fahrenheit. It's hot enough to bake a cake. But let's get back to our volcanic hotspots. Scientists still don't clearly understand why there aren't many hotspot volcanoes on continental crust. One reason might be that the continental crust is much thicker than the oceanic crust, which is about 4 times as thick on average. Another reason could be that most of Earth's crust, about 2/3 of it, is oceanic. This means that there's less continental crust for hotspots to form under. Now, I bet those of you living in Arizona will appreciate the following info. We'll talk about a volcanic field right in the heart of this state, the San Francisco Volcanic Field. That's a massive area filled with over 600 volcanoes. Yes, they're mostly small, but it doesn't make them any less impressive. They're scattered across 1,800 square miles in northern Arizona, a giant territory. Interestingly, scientists are still debating about whether this volcanic field is actually sitting on top of a hotspot. But one thing they agree upon, the volcanoes in this area get younger as you move east. And this pattern matches up with the North American plate moving west over what could be a stationary hotspot beneath the surface of our planet. Cool, huh? The volcanic hullabaloo in that area started around 6 million years ago. So, in geological terms, it's relatively young. As for the most recent eruption, it happened less than 1,000 years ago. The Sunset Crater, which I mentioned before, the one near Flagstaff, is the most famous vent from that eruption. The Sinagua people had to leave their homes at Wupatki Pueblo because of the eruption. That site is now part of the Wupatki National Monument. There, you can see how people lived in this volcanic region many years ago. If you go to explore this area, you'll notice that most of the volcanoes there are basalt cinder cones, small and steep. The Colorado Plateau has quite dry weather conditions. That's why the volcanoes haven't worn down much. Some of the best examples of those cones, like this one, called the SP crater, still look like they appeared yesterday. But look around. It's not just cinder cones. The San Francisco Volcanic Field also has a stratovolcano, as well as some lava domes that formed from volcanic rocks with more silica than basalt you can find in places like Hawaii. It means they're thicker and don't flow as easily. Anyway, the stratovolcano is going to be one of the most epic sights you'll come across while exploring this volcanic field. Well, not the stratovolcano itself, but the San Francisco peaks, the remains of that giant formation. They stand tall at more than 12,600 feet. That's 4.5 Burj Khalifas placed on top of one another. It makes the peaks some of the biggest landmarks in northern Arizona. They're not only stunning, but also sacred to the Native American people who have lived in the area for many generations. Now, unlike those super active volcanoes in Hawaii, the San Francisco volcanic field takes its time, thousands of years between eruptions. But you shouldn't relax just yet. Geologists say another eruption is likely to happen one day. It will probably occur in the remote eastern part of the field, away from big towns. Phew! And if that next eruption is anything like the one that formed Sunset Crater, it would be quite the show. Lava fountains and rivers of lava flowing. At the same time, the next eruption might not happen for centuries, maybe even millennia. Until then, the San Francisco volcanic field will remain a hidden gem of volcanic history, waiting for its next fiery performance.
The scariest legend from Norse mythology, Ragnarok, could have been inspired by true events. Yeah, that story where Thor and the other deities go down fighting and the whole world ends, only to start later again. Around the mid-6th century of the current era, two massive volcanic eruptions took place on the American continent. These eruptions sent huge amounts of gas and sulfur dioxide into the air, which made the climate much colder across the northern hemisphere, including Denmark. In old records from China during those times, they wrote the sun got dim and cold like the moon. Grain crops couldn't ripen properly, and stars were hidden for over a year because of the volcanic particles that still lingered in the sky. Scientists wanted to understand how this colder weather affected trees, so they studied the growth rings of Danish oak trees from around that time. They wanted to see how the shift in weather patterns affected tree growth during this period. The scientists compared tree samples from Denmark with ice core samples from Greenland. These ice cores hold layers of snow and ice that trap tiny bits of sulfur and other particles from past volcanic eruptions, so they can show when these eruptions occurred. The tree rings show that the trees grew less than normal in the middle of the 6th century, so the weather was much colder than usual, probably because of volcanic ash in the sky. Some farms were abandoned during that time, and nature began to reclaim these areas. All this may have caused big shifts in society, like changes in village structure and ritual practices. Archaeologists have also found many valuable objects buried during that time. It looks like people were trying to offer them to deities to bring back the sun. They feared that an endless winter before Ragnarok would start if they didn't do something. A long time before that, in what is now England, people were busy building Stonehenge. There's no debate that the larger stones were brought there by humans, but there's a new theory about the smaller so-called blue stones. They don't seem so blue on a sunny day, but they do have a bluish tinge when rain falls on them or you break them, so be careful. So the main theory is that our Neolithic ancestors worked hard to bring the stones from the Preseli Hills to Salisbury Plain. A new study suggests that long ago, during the Ice Age, glaciers might have used the Bristol Channel as a highway to move rocks. They found a large, unusual rock called a glacial erratic in Limeslade Bay. A glacial erratic is a rock or boulder moved from its original home by a glacier to a new place. The rock in Limeslade Bay is made of a type of stone called dolerite, which isn't found in the Bay Area. But it matches rocks from North Pembrokeshire, which means it likely traveled by glacier to its new location. A massive glacier from the Irish Sea must have picked up this huge rock in Pembrokeshire and carried it southeast, then east, right up the Bristol Channel. They also found other glacial erratics along the Bristol Channel, which only supports this idea. So, if the new theory is correct, it means that Neolithic people didn't carry the bluestones to Salisbury Plain, but found them already there and decided to use them to build Stonehenge. Now, if you don't like shopping lists, try thinking of them as historical documents that someone will find, say, 3,500 years from now. Archaeologists in a region of Turkey that was known for the production of pottery, metal, and glass found one shopping list that was this old on a clay tablet. It's roughly the size of a large postage stamp and was made by people who lived in Mesopotamia. They used a very old type of writing called cuneiform, which means wedge-shaped, as it was made up of marks that look like wedges. The language written on this tablet is called Akkadian, and it went extinct long ago. They used sounds to make words, just like we do today. To write these sounds, they borrowed symbols from an even older language called Sumerian. The tablet itself is a kind of shopping list left by people who were buying a large amount of furniture. They mention tables, chairs, and stools. This record helps us understand how people in the late Bronze Age kept track of goods, money, and trade. Looks like they had an organized system for buying and selling things. Meanwhile, the Bronze Age shopping list is a youngster compared to what is thought to be the oldest calendar in the world. It shows the fall and impact of a comet from around 13,000 years ago. The carving is part of the Göbekli Tepe temple complex in Turkey. Talk about alliteration. It has large round stone structures and pillars that are carved with pictures of animals and symbols. People in the Neolithic period, around 11,000 years ago, built the temple, and it might have been used for something like a giant observatory for watching the night sky. One of the most interesting objects at the complex is a tall carved vulture stone. This stone has the image of a bird and other designs on it. One scientist who studied it thought the designs might show constellations. The carvings could tell the story of a huge comet that changed the weather patterns on Earth and caused a mini ice age. There are small V-shaped marks on the pillars at Göbekli Tepe, which could be used for counting days, and other stones could show big celestial events, like meteors or comets passing by. Archaeologists in Italy, near the ancient city of Naples, were checking the ground to change the city's water pipes when they found a tomb that is about 2,000 years old. It had been well preserved, with paintings on the walls that show scenes from myths and ceilings that haven't faded. This tomb of Cerberus was named after the most famous painting you can find inside. Cerberus was a creature from Greek mythology, a huge, scary dog with 3 heads. He was known as the guard dog of the underworld. One famous myth you can see on the walls of the tomb is the story of Hercules capturing Cerberus as part of his 12 labors. As the archaeologists kept digging, they discovered images of ichthyocentaurs, creatures that were like a mix between a mermaid and a centaur. The tomb also has a large altar with vessels for liquids that they would pour out as an offering to honor the deities. The person who was buried here lies on a decorated burial bed, surrounded by paintings, symbols, and objects that people in ancient times believed would bring peace or help in the afterlife. The tomb was just found in October 2023 and is not open to visitors yet, as archaeologists are still studying it. Scientists have long wondered how heavy stone blocks were carried to the sites of the pyramids in Egypt, and they might finally have an answer. Researchers from the University of North Carolina, Wilmington, believe that the ancient Egyptians built 31 pyramids along an ancient branch of the River Nile. It's now hidden under desert and farmland. It's not a new idea, but up until recently, scientists weren't sure of the location, shape, size, or proximity of the waterway the pyramid builders could have used for transportation. This time, they used radar satellite imagery, historical maps, geophysical surveys, and sediment coring to map the river branch. A major drought and sandstorms likely buried it thousands of years ago. The team managed to go below the sand surface and get images of some hidden features thanks to radar technology. They found hidden rivers and ancient structures running at the foothills of where most of the ancient Egyptian pyramids lie. Thanks to this discovery, we can now understand why they decided to build so many pyramids between Giza and Lish in what is now an inhospitable area of the Sahara Desert. Our planet's biggest and meanest supervolcanoes are waking up. When they erupt, you'll surely notice it, even if you live thousands of miles away from the epicenter. Scientists are worried we might not have enough time to prepare and deal with the consequences of a supereruption. There's some volcanic activity close to the Italian city of Naples. And no, it has nothing to do with the famous Mount Vesuvius, but with another volcano. This one is harder to see as it doesn't have a tall peak like Vesuvius. But don't let this bad guy trick you. It could be way more dangerous than its giant neighbor. It does have a huge crater that's about 8 miles wide. This volcano is called Campiflagre, and it's actually one of the largest volcanoes in Europe, sitting under the town of Pasquale. So, Campiflagre erupted 39,000 years ago with a bang so massive it spread ash across the whole Mediterranean region. It also caused the temperature to drop by over 16 degrees Fahrenheit across Eastern Europe. It was the biggest volcanic eruption in Europe in 200,000 years. Since then, Campiflagre has had smaller eruptions, and the last one happened in 1538. Now the area is full of small craters, hot springs, and bubbling pools, and they're all proof that this volcano is still very much alive and brewing something. Since the early 2000s, the ground in the giant crater and the town nearby have been slowly rising by about 1 to 1.5 inches every year. There were at least 150 earthquakes that shook this supervolcano lately. In May 2024, there was a 4.4 magnitude in the area, the biggest in the last 40 years. Residents had to leave their homes and camp outside, fearing there would be more earthquakes. No one knows how Campiflagre is going to behave in the following months or years, but the authorities are organizing evacuation exercises to prepare the population just in case. The Italian volcano looks like an innocent kitten compared to the real giants like Yellowstone. For a volcano to deserve the title of a super one, it must be able to produce catastrophic-scale eruptions and eject huge amounts of magma, ash, and volcanic gases. The Yellowstone giant meets these criteria. Even though it moves from time to time, the Yellowstone supervolcano hasn't erupted for 640,000 years. But when it does wake up, it might erupt with incredible power, about the same amount as 10 huge nuclear power stations can produce. Under the ground, beneath Yellowstone, there's a super hot area full of molten rock called magma. As more magma moves into a big space called a magma chamber, the ground above starts to swell or rise. When the magma cools down, the ground falls. Between 2004 and 2009, the ground at Yellowstone rose by almost 10 inches, but then it started to slowly go back down in 2010. Scientists aren't sure if it's going to erupt anytime soon. There's also another big volcano called Long Valley in California that has been active since 1980, and it can be a really big threat. Scientists studying this supervolcano found out that before its biggest eruption, 760,000 years ago, the buildup may have taken less than a year. Now, that's bad news, because a supervolcano eruption can have a huge effect on the world, like the eruption of the Toba volcano in Sumatra around 74,000 years ago. It became the biggest volcanic eruption the Earth had seen in 28 million years. It covered parts of Indonesia, India, and the Indian Ocean with a thick layer of volcanic debris, almost like a 6-inch blanket. The amount of rock it spewed out was like stacking nearly 3 million Empire State Buildings. The giant crater it left behind can still be seen from space. All the ash and gases shot up into the air and blocked some of the sunlight. It caused a volcanic winter that lasted about 6 to 10 years. Some scientists think this eruption might have even affected early humans. Around the time Toba erupted, the human population took a sharp dip, and there were far fewer people. Some say this is why all modern humans come from a small group of survivors. According to the Toba catastrophe theory, most early humans in Europe and Asia didn't survive the cold and harsh climate after the eruption, but a lucky group lived through all that in Africa. Not all scientists agree with this idea, and some archaeological and climate records show a different story. Another volcano that changed the world in a big way was Mount Tambora in 1815. The next year went down in history as the year without a summer. It was cold and rainy, and there was snow and frost even in the middle of summer, especially in Europe and North America. This happened because the volcano sent out a lot of sulfur dioxide into the sky, which spread all over the world and made the planet colder. When Tambora erupted, it caused huge tsunamis that smashed homes and took the lives of around 10,000 people. Afterward, about 80,000 more people passed away because of the consequences the eruption had caused in the world. The cold weather ruined crops, so food became really expensive. And because horses were the main way people traveled, the cost of oats that they ate went way up too. Some people even think this led to the invention of the bicycle in 1817. as a new way to get around. The eruption made the Earth colder for about 3 years. Now, even though the Tambora eruption was so powerful, Krakatoa, another volcano in Indonesia, stole the show when it erupted in 1883. It was just easier to spread information about it through telegrams and photos. Its final blast was the loudest recorded sound in history, and people could hear it on 10% of the entire Earth's surface. The eruption started a tsunami, with waves about half as tall as the Statue of Liberty. Now, if we only had 12 months to prepare for a supervolcano eruption, it would be really hard to store enough food and get ready. But don't panic just yet. Supervolcano eruptions are very rare, and the last one happened 26,500 years ago in New Zealand. Scientists think that a super eruption happens once every 100,000 years on average. But the sad part here is that the Earth doesn't follow a perfect timeline. There could be clusters of super eruptions with shorter gaps between them and then longer quiet periods. Since there have already been 2 super eruptions in the last 100,000 years, there's always a chance one could happen again sooner than we expect. Plus, although there are places like Yellowstone and Long Valley where we expect volcanoes to erupt, there are less obvious possible hotspots. In Chile, there's a volcano called Laguna del Maule that has erupted in the past and left behind a huge crater. Over the last 20 years, the ground there has been swelling really fast, rising up to almost 1 foot a year. Some people are worried that this could be a sign of a big eruption coming. But scientists say there's not enough magma yet to cause a super eruption. In Bolivia, the Juturancu volcano is also acting up. It's part of a group of volcanoes that have caused super eruptions in the past. Since the 1960s, the ground around Juturancu has been lifting, but the last eruption was 250,000 years ago. Even though the magma might be rising, it's not enough to worry about just yet. The chances of a super eruption happening during our lifetime are 1 in 1,400, which is pretty low, so you don't need to worry too much. But just like someone wins the lottery every week with very small chances, a super eruption could happen sometime in the future, and when it does, we'll need to be prepared.
Phew, you can finally send that last report for the day and breathe out. The weekend is around the corner, but just when you're about to hit send, you're alarmed by the low rumbling under your desk. Is it the light rail passing by? Unfortunately, that's not the case. It's a volcano speaking. What, here? In Arizona? That's right, the ground keeps shifting under Arizona, reminding us that Earth is alive. No panic though, let's arm ourselves with some context. 20 American states have extinct, active, and dormant, currently sleeping, volcanoes. Among such states, you can find California, New Mexico, Nevada, Utah, and Colorado. On the bright side, Arizona's volcanoes are dormant at the moment, but it doesn't mean they won't go off in the near or not so near future. Now, how about traveling to Arizona to check the traces of its active volcanic past? They dot the desert landscapes of this state like spots dot a Dalmatian. There are entire volcanic fields southwest of Phoenix, east of Douglas, near Flagstaff, north of Kingman, and near the Mexico border. The most worrying thing about these fields is that even though they're not active at the moment, eruptions in this region might happen every 1,000 years or so. Well, the time seems to be up. The last powerful and destructive volcanic eruption occurred around 1,000 years ago at the Sunset Crater. Oh, this place is worth paying more attention to. And we will, but a bit later. First, we have to talk about hotspots. No, not that place where you can surf the web. In our volcanic context, a hotspot is a place where insane amounts of heat melt the overlying crust, Earth's thin outer layer, and form volcanoes. This heat rises from the mantle, which is located between our planet's dense, superheated core and the crust. Want to see an example of this type of volcanism? Welcome to the Hawaiian Islands. The Big Island has its active volcanoes because, at the moment, it's situated on top of the Hawaiian hotspot. The older Hawaiian Islands were once there too, but later they drifted off towards the northwest. It happened because that's where the oceanic crust on top of which they sat, namely the Pacific Plate, moved. Now, look at the world's ocean basins. Yes, they're literally dotted with islands that sit on top of hotspots, like Hawaii, Iceland, Samoa, the Galapagos. Those are probably the most famous examples. But don't think that continents can't host hotspots. They can, but those are far less common. One of the most famous continental hotspots is, I bet you know it. Yep, the one beneath the Yellowstone caldera. By the way, the caldera is a vast volcanic crater, especially one formed as a result of a massive eruption that led to the collapse of the mouth of a volcano. The Yellowstone hotspot is basically the creator of Old Faithful and the rest of the hot springs and mud pots for which the national park is famous. Speaking of Old Faithful, let's make a small detour and pay more attention to this wonder of nature. It's one of the most well-known geysers in the world. People have been coming from all over the globe to see it for more than a century. The cool thing about this geyser is that the likes of it can only form under very specific conditions. That's why they're pretty rare. Magma under the surface superheats pockets of underground water. The pressure there keeps growing until it eventually pushes the water upward with immense strength. A certain volcanic rock with a high silica content lines the tunnel through which this water escapes. Basically, it creates a unique pipe that can withstand unbelievable pressure and heat created by the water erupting above the ground. Old Faithful was the very first named geyser in Yellowstone. If you come to visit it expecting the thing to erupt every hour on the hour, you're gonna be disappointed. On average, Old Faithful erupts every 91 minutes or so, which isn't that bad either. Plus, you can download a special app which will provide you with the approximate time of the next eruption. But be very careful while visiting and stay away from the site. The water erupting from the powerful geyser reaches 204 degrees Fahrenheit. The steam is even more scorching, up to 350 degrees Fahrenheit. It's hot enough to bake a cake. But let's get back to our volcanic hotspots. Scientists still don't clearly understand why there aren't many hotspot volcanoes on continental crust. One reason might be that the continental crust is much thicker than the oceanic crust, which is about 4 times as thick on average. Another reason could be that most of Earth's crust, about 2/3 of it, is oceanic. This means that there's less continental crust for hotspots to form under. Now, I bet those of you living in Arizona will appreciate the following info. We'll talk about a volcanic field right in the heart of this state, the San Francisco Volcanic Field. That's a massive area filled with over 600 volcanoes. Yes, they're mostly small, but it doesn't make them any less impressive. They're scattered across 1,800 square miles in northern Arizona, a giant territory. Interestingly, scientists are still debating about whether this volcanic field is actually sitting on top of a hotspot. But one thing they agree upon, the volcanoes in this area get younger as you move east. And this pattern matches up with the North American plate moving west over what could be a stationary hotspot beneath the surface of our planet. Cool, huh? The volcanic hullabaloo in that area started around 6 million years ago. So, in geological terms, it's relatively young. As for the most recent eruption, it happened less than 1,000 years ago. The Sunset Crater, which I mentioned before, the one near Flagstaff, is the most famous vent from that eruption. The Sinagua people had to leave their homes at Wupatki Pueblo because of the eruption. That site is now part of the Wupatki National Monument. There, you can see how people lived in this volcanic region many years ago. If you go to explore this area, you'll notice that most of the volcanoes there are basalt cinder cones, small and steep. The Colorado Plateau has quite dry weather conditions. That's why the volcanoes haven't worn down much. Some of the best examples of those cones, like this one, called the SP crater, still look like they appeared yesterday. But look around. It's not just cinder cones. The San Francisco volcanic field also has a stratovolcano, as well as some lava domes that formed from volcanic rocks with more silica than basalt you can find in places like Hawaii. It means they're thicker and don't flow as easily. Anyway, the stratovolcano is going to be one of the most epic sights you'll come across while exploring this volcanic field. Well, not the stratovolcano itself, but the San Francisco peaks, the remains of that giant formation. They stand tall at more than 12,600 feet. That's 4.5 Burj Khalifas placed on top of one another. It makes the peaks some of the biggest landmarks in northern Arizona. They're not only stunning, but also sacred to the Native American people who have lived in the area for many generations. Now, unlike those super active volcanoes in Hawaii, the San Francisco volcanic field takes its time, thousands of years between eruptions. But you shouldn't relax just yet. Geologists say another eruption is likely to happen one day. It will probably occur in the remote eastern part of the field, away from big towns. Phew! And if that next eruption is anything like the one that formed Sunset Crater, it would be quite the show. Lava fountains and rivers of lava flowing. At the same time, the next eruption might not happen for centuries, maybe even millennia. Until then, the San Francisco volcanic field will remain a hidden gem of volcanic history, waiting for its next fiery performance. The story of Pompeii is complete chaos as is, but to add a little fuel to this fire, we dug up some groundbreaking facts, and I mean that quite literally. Hear me out. What if it wasn't the scorching sea of lava that destroyed the city of Pompeii, but rather an earthquake that happened during the volcano's eruption? Rewind to over 2,000 years ago. The year is 79 BCE. It was around 1 o'clock in the afternoon when Mount Vesuvius decided to erupt. Pompeians were going on with their normal daily routines when lava started taking over. The flow of lava was so quick that most people didn't have anywhere to run. The disaster took the lives of around 2,000 people. The lava covered most of the city, which then turned everything to ashes. Pompeii was only discovered during the 16th century of our Common Era, when an architect commended a dig to divert a river. It's a very well-studied site nowadays, but something unusual recently caught the researchers' attention. Scientists were excavating a site called the House of Painters at work. They were examining a couple of skeletons when they saw something weird. The skeletons probably belonged to two men around the age of 50. The analysis showed these men had survived the first surge of lava in the city, but they didn't make it out due to this second unexpected part, the earthquake. The men probably took shelter at the House of Painters at work, but the walls crumbled down when the earthquake hit. The men were found in a protective posture, like they were trying to shield themselves from something that was going to fall above their heads. Plus, these skeletons were not found under the layer of volcanic ash, but on top of it, proving that they really did survive Vesuvius's sea of lava. It turns out this is not as rare as it seems. A volcanologist explained that the seismic activity during the eruption really made things worse in Pompeii. He said that this seismic chaos probably influenced the desperate choices of a lot of Pompeians in their final moments. This is not the first time the world heard of a possible earthquake in Pompeii. A guy named Pliny the Younger, who escaped the disaster and witnessed the whole thing, beat these scientists to it in his famous letters. Pliny the Younger was a lawyer and an important person back in ancient Rome. He was an eyewitness to the whole Pompeii disaster, and he wrote in one of his letters that the eruption was followed by a trembling of the earth. Researchers do agree that something never added up. Pompeii is known to have really well-preserved skeletons since the ashes kind of played an important role in preserving them. But the buildings were in horrible shape, making it hard to reconstruct the entire city as it once was. Pompeii was indeed one of a kind. It was one of the most vibrant and lively cities of the ancient Roman Empire. The city was huge. It could have been home to as many as 30,000 people in its heyday. The House of Fawn, for example, was a clear example of how rich Romans lived their lives in Pompeii. It was a huge house that even had 2 gardens inside, taking up the entire block. They looked like they were made of white marble, but it was actually painted stucco. It was clear to researchers that only aristocrats lived there. Then there was this famous forum. This is where most of the administrative part of the city life happened. It was made up of a lot of different buildings, like the Basilica, a hotspot for political and civil meetings, the Macellum, which was a market, and several temples. If we were visiting this back in the day, we'd see a bunch of men dressed in tunics. A few select ones would wear togas, those heavy white pieces of draped cloth that look like bed linen wrapped over the body. Togas were mainly used on special occasions since they were costly, hard to wash, and considered a traditional costume. Representatives running for office would use it during their campaign run so that commoners would identify them as candidates. One can't forget about the Villa of the Mysteries. Cool name, huh? It was called that way because of some mysterious frescoes found inside of it. Modern-day archaeologists still haven't figured out what the scenes painted are trying to depict. Probably some type of ritual or ceremony. By the way, a villa is simply a large suburban Roman-style house. It's not necessarily a super posh place where the rich and beautiful live. It's usually located on the outskirts of town, near the city's walls. The Villa of the Mysteries one in particular was found astoundingly well preserved in modern archaeological excavations. It even had a manufacturing area inside of it, like its own little industry. It was common for richer Romans to own big farmlands, like olive gardens, for example. So they would also build a processing station inside their villas to extract the oil and package the whole thing. The amphitheater was where some of the richer men paid to put on gladiator fights for the rest of the town. It was built around 70 BCE, and it was one of the oldest amphitheaters of the world. It was even older than the Colosseum in Rome. This huge building could fit around 20,000 spectators at once. The seating was arranged by social class, so you could easily spot who was a member of the nobility. And in case you're wondering why it was shaped like a weird egg, it's because that was the shape that allowed for an unobstructed view wherever you were in the crowd. As every other Roman city, Pompeii also had some famous baths. Since not every house had access to plumbing back in the day, most people didn't shower in their homes. That's why so many Romans would use public baths, usually at the end of the day, to clean themselves. But make no mistake, this wasn't just a place for bathing, it was a cultural hotspot. The baths were made up of many different rooms. The first one was like a locker room, where people would keep their clothes and personal belongings. This is where the upper and lower classes mingled together. Someone's class could easily be identified by their clothes and jewelry. The amount of gold and silver worn back in those days is nothing compared to what most people wear today. Usually, the rich folks would leave someone to take care of their belongings while they went and took their bath. Because yes, it could happen that stuff went missing while chilling and relaxing. The big focus on self-care nowadays was already a thing for ancient Romans. It was common that before taking a bath, olive oil was rubbed all over the skin. They would scrape off the dirty skin with a strigil. That may sound weird, but also extremely pleasing. The baths had rooms for massages. Some of them had reading rooms, and even courtyards for some healthy exercise. Oh, there was even a natatio, or swimming pool if you're not fluent in Latin. After all, it was the Romans that said, a healthy body is a healthy mind. The bakeries. Bread was one of the main components of Pompeian diet, so much so that there were around 30 bakeries in the city. Bread was freshly made from scratch every day. In a special area of the shop, the corn or wheat was ground, and mules would circle around to keep the mills going. The funny thing about Pompeians is that they like to cover the exterior walls of buildings with paintings, much like graffiti nowadays. Their paintings, usually frescoes, used to depict what daily life was like in the city. Ancient Romans were very outdoorsy people, so coloring their walls seemed like a good option for them. A lot of houses had frescoes inside of them too, to make up for the lack of windows. The paintings gave the house owners the illusion of more space if the painting was of, let's say, a garden, for example. The last time this volcano erupted was about 500 years ago, but recently, small tremors have grown really frequent, to such an extent that scientists have been recording more than 1,000 a month. I'm talking about the Campi Flegrei supervolcano in Italy. At one point, just a few weeks ago, the area was rattled by a 4.4 magnitude earthquake with 150 tremors in just one night. It was the strongest earthquake in over 40 years. A lot of locals spent the night in their cars, but in the morning, the shakes were followed by another earthquake, a bit weaker with a magnitude of 3.6. So, is Italy in danger? Well, the quake itself wasn't big enough to cause serious damage, but it evoked a lot of panic. At the moment, local authorities are working on grandiose emergency plans. If worse comes to worse, they'll have to evacuate hundreds of thousands of people. One of the reasons is the proximity of this area to Naples with more than 3 million inhabitants. At the moment, they're even considering an option of paying people to leave their homes. Right now, schools remain closed in the Campi Flegrei area. The authorities are allocating more than 500 million euros to ensure the safety of buildings and constructions in the area. A yellow alert is still in place in the region where 80,000 people live. There's the so-called red zone, which is the most dangerous area. There are 1,250 houses in this red zone, and all of them will be at high seismic risk if an eruption begins. Plus, more than twice as many will be at medium risk. Italy is a country prone to seismic activity, and Pozzuoli is a densely populated area that is located on one of the most dangerous supervolcanoes in Europe. Campi Flegrei has 24 hidden underground craters and dwarfs the better-known Vesuvius. Yes, the very volcano that wiped the ancient Roman city of Pompeii off the face of the earth in 79 CE. This city thrived near the base of Mount Vesuvius at the Bay of Naples. In the time of the early Roman Empire, 20,000 people lived in Pompeii. They were merchants, manufacturers, farmers, and others. The soil in the region was rich and fertile, so there were lots of orchards and vineyards. Strangely, no one knew that this black earth was the legacy of an earlier eruption of Mount Vesuvius. The area was a favorite summer destination for rich Romans. Sadly, at noon on August 24, 79 CE, all this prosperity came to an end. The peak of Mount Vesuvius exploded, sending a 10-mile-high mushroom cloud of ash and pumice into the stratosphere. For the next 12 hours, the eruption was wreaking havoc on the city. Volcanic ash and a hail of pumice stones, some of which were 3 inches in diameter, showered Pompeii. It forced the city's occupants to flee in terror. Around 2,000 people holed up in stone structures and cellars, paralyzed by fear. They hoped to wait out the eruption. Who knows? Maybe if they had decided to leave the city immediately after the beginning of the eruption, they would have had some chances to survive. A westerly wind protected the city from the first stages of the eruption. But soon, a giant cloud of hot ash and gas rushed down the western slope of Vesuvius. It engulfed the city, burning everything in its way. This disastrous cloud was followed by a flood of volcanic mud and rock, which completely buried the city. As if the volcano was making sure no one would survive, a cloud of toxic gas poured onto the city, finishing the lives of a few survivors on August 25th. A flow of rock and ash followed. It collapsed roofs and walls and turned the city into a giant cemetery. When a supervolcano erupts, the consequences are usually catastrophic. Supervolcanoes have at least once had an eruption with a volcanic explosivity index of 8, which is the largest recorded number on the index. Supervolcanoes are often extremely large, with no cone at all. That's because they're typically the remains of gigantic magma chambers that once flared up, leaving behind a caldera. They're usually located over hotspots and appear when huge volumes of magma are trying to escape from deep underground. Eventually, they burst through Earth's surface. Sometimes, all this magma gets stuck, unable to break through the planet's crust. And then, Massive pools of pressurized magma gather at a depth of several miles. The pressure keeps growing because more and more magma is trying to get to the surface. At one point, a super eruption goes off. The most recent super eruption happened in New Zealand. Well, when I say recent, I meant around 26,500 years ago. That's when a supervolcano beneath the surface of Lake Taupo spewed into the air more than 300 cubic miles of ash and pumice. Imagine 500,000 Great Pyramids of Giza flying up into the air at the same time. That's how incredibly powerful that eruption was. But the most exciting and confusing thing about the eruption was that the Taupo volcano didn't simply go off like many others. At first, everything was going as usual. Tons and tons of pressurized magma had built up under the surface, and the pressure was getting higher and higher. But after the rock cracked and the first portion of lava rushed out of the crater, something went wrong, and the supervolcano took a break. Only several months later, the disastrous eruption shook the ground. Thousands of tons of lava, rocks, and ash flew high into the atmosphere. The unusual pattern of Taupo still confuses scientists. The Indonesian eruption at Toba Caldera 75,000 years ago was the largest eruption in the last 2 million years. Experts estimate that the eruption could have released hundreds of thousands of tons of sulfuric acid, which might have even caused a several-degree cooling of the planet's surface. But nowadays, the impact is hard to detect because of glaciers that covered the ground afterward. There are also several so-called supervolcanoes that haven't lived up to this name yet because they've never produced any super eruptions. For example, in 1883, Indonesian volcano Krakatoa went off. The power of the eruption tore the volcano's walls open, and cold seawater rushed into its molten insides. The difference in temperatures made the volcano blow up with a deafening boom. It was clearly heard 3,000 miles away in Australia. It earned the blast the title of the loudest sound in history. But even though the consequences of this event were truly catastrophic, it still turned out not powerful enough to be called a super eruption. It only had a volcanic explosivity index of 6. Then, there's also Mauna Loa. It's a shield volcano, which means it won't produce explosive eruptions, but its sheer size makes this monster of a volcano extremely dangerous. At the moment, the volcano seems to be at peace with its surroundings. Research equipment doesn't show any signs of activity on Mauna Loa, but if Mauna Loa did suddenly erupt, lava flows could reach the ocean and the most populated and touristy places like Captain Cook very fast, in a matter of hours. The last time the volcano erupted, lava got as far as the outskirts of Hilo on the other side of the island. That's where the University of Hawaii is located. Luckily, people had a few weeks' warning to get ready for the disaster. Over its recorded history, Mauna Loa has been erupting pretty regularly, almost every 6 years. On the bright side, big island volcanoes including Mauna Loa aren't really very volatile. That's because they're shield volcanoes. These volcanoes got such a name because they aren't really very high and resemble a warrior's shield placed flat on the ground. Shield volcanoes are formed by very fluid lava. It travels way farther and forms much thinner flows than the lava erupted from a stratovolcano, which is conically shaped and tall, like the infamous Krakatoa in Indonesia. So, if Mauna Loa erupts, there probably won't be ash clouds or tons of debris. The most dangerous thing will be lava. Since Mauna Loa is a shield volcano, its lava is extremely fluid and voluminous, which allows it to flow far and fast.